Hello, hello, hello. Hello, hello. Let's make sure we got volume. Do we have volume? Yeah. Okay, everyone. So we're going to start off by finishing free response 2. And I think before we finish that off, what I would like to do is take another look at letter E with one standard deviation. And this time when I do it, I'd like to actually look at the curve. So I'm not sure if we figured this out explicitly or said it explicitly or not, but the z-score is the same thing as standard deviation. It tells you how many standard deviations away each measurement is. So this is my attempt right here at drawing a standard normal curve, or something approximately normal. And I'm going to mark things here. The z-scores are going to go on top, 0. The diameters are going to go on the bottom, 11.5. And we already figured this out. This right here is -1, a z-score of -1, and has a measure of 7.658. And a z-score of +1, we already figured that out. That has a measure of 15.342 and a z-score of +1. So basically what I'm saying is this middle part right here, this is 68%. That is the empirical rule, or at least the first part of the empirical rule. This is all 68%. 68% are within 1 standard deviation of the mean. Or another way of saying it is 68% of the measurements are between a z-score of -1 and a z-score of +1. Okay? Next, let's take a look at question. What is that? Question F? Okay. Free response 2, question F. Just so you know, you're not going to get questions all the way to free response F tomorrow. We just started. But I think what I want to do before I start this one is to actually, again, look at this so-called single peak symmetric distribution, this bell curve. That looks a little bit better. It looks like it's leaning a little bit to its left, but whatever. And I want to do the same thing where I notate where things are. So we'll do this again. This is a z-score of 0. This is a z-score of 1. This is a z-score of, I'm sorry, this is -1. This is a z-score of +1. This would be a z-score of 2, -2. This would be a z-score of +2. And I know 3 is out here somewhere. -3, and of course, +3. I'm going to note these on the bottom. That's 11.5 inches in diameter. We said that this is 7.658 inches in diameter and 15.342 inches in diameter. If my memory serves me correctly, this is 3.816.
Yes.
Thank you. 3.816 inches in diameter. This is 18. I don't remember.
I think it's 19.184.
19.184 inches in diameter. And I think that's all we need here. We want to figure out what are between, what percentage are between 3.816 and 11.5. Okay? So first of all, let's figure out where 11.5 is. It's right here at the mean. Let's figure out where 3.816 is. That's right here at a z-score of -2. Okay? So the first thing we need to do is let's remember that the area to the left of a z-score of 0, that area is 0.5. That's one of the ones you're supposed to memorize. The next thing to memorize, the area to the left of a z-score of -2, that area is 0.025.
This is for like Ollie.
This is for single peak symmetric distribution. So the empirical rule for symmetric distribution, there are a whole range of them that you needed to memorize or quickly compute. These are just 2 of them. And so if you want to figure out the area here, I think it's just going to be this yellow part right here, which I'll highlight. And of course, here's that blue part. So it's going to be 0.5 minus 0.25. That would be the area. So that's going to be equal to 0.5 minus 0.025, and that gives you 0.475. So that's approximately 47.5%. Between those 2 diameters, 3.816 and 11.5.
Can you explain what the 0.025 and 0.5 are? Those are the areas for the
Yeah,
z-scores?
that's the area for the z-score. Let me show you where that comes from. Let's remember that if we have a z-score, well, first of all, at a z-score of 0, the 2 areas here are 0.5 and 0.5,
Okay, I get it.
right? And then remember at a z-score of 1, z-score at 1, this is 0.68 and this is 0.14. 0.14. That's too small. That kind of looks like Darth Vader's helmet, doesn't it? Yeah.
They say like single peak asymmetrical.
Yeah. And then the other one to memorize is this one. 2 standard deviations. This is 95% in the middle, and then 2.5% at the ends. Okay?
Yeah, thank you.
Yeah.
What does the -1 and the 1 mean?
Those are z-scores. Yeah. Standard deviation or z-scores. Yeah. I hope you have a bowl. Yeah, who is that? Sharon? Could you reach down there and get like one of the glass bowls for this guy?
Wait.
On the right side. Top shelf, right side. Yeah. G. G. Using the empirical rule.
Okay, the number is minus the mean over the standard.
We want to know empirically what's the percentile rank. So first thing we should probably figure out is what does percentile rank mean? So in terms of a distribution, the percentile is the area to the left. So basically, this question is asking you what is the area to the left of 15.342. Recall for me that 15 was a z-score of positive 1. What was it, 15.342? Has a z-score of positive 1. And then remember that what we said was when you have a z-score, it's like a map. It tells you where this thing lines up under this bell. So positive 1 lines up right here under the bell. Okay? Do we remember that? Great.
Then 2 is when it starts moving a little bit more.
Yeah.
So 2 is like right, yeah.
Yes.
Okay, so when you're finding, so okay, I'm just a little confused on the observation. It's just observation minus the mean over the standard deviation. So the observation would be the average height.
No, the observation is 15.342.
Is it always going to be that? Like, would it always be the side of the bell?
No, that depends on what the z-score is. Okay, the z-score tells you where in this bell are you.
Okay, so the z-score is just a vertical line, right? That goes through.
Well, no, the z-score are these numbers up here.
Oh.
And depending on where you slice it, for example, if you slice it here,
Okay.
the z-score is 0.
Okay, because that's directly in the middle. Okay.
Yes.
Wait, where did you get 15.342?
They gave it to you.
Oh, okay. Okay, I was looking for it.
Alright, so that's 15.342. That has a z-score of 1. And now that we're using the empirical rule, we know a lot about this. In fact, we just wrote it down. Here, we wrote down that the area to the right of a z-score of 1 is 0.14. Again, please look here, make sure you got this. We just wrote down this Darth Vader helmet here. And we just saw that the area to the right of a z-score of 1 is 0.14. Did everyone agree with that? So I'm going to put a 0.14 here.
Wait, you wrote down?
Is it 0.16?
Yeah.
I'm sorry, that should be 0.16. You're right then. Let me erase that with the eraser. So sorry. You would think I'd have that memorized. But I actually just use my calculator most of the time. Okay, so that tells me the area to the right is 0.16. The last key here is we want to find area to the left. So the area to the left, if you remember, this entire bell has to add to 1. So because the entire bell adds to 1, the area here is 0.84. If the area to the left is 0.84, left of 15.342 is 0.84. The percentile rank of 15.342 is also 84%. Percentile rank is the same thing as area to the left. Is he having problems?
Isn't it 82?
82?
Like, did you round
It's approximately 84.
Oh, did you round it?
No, we're only using the empirical rule right now.
Okay. Because I was like looking at how you know how you said +1 and -1, it's always the middle is like 0.68. So for the empirical rule, what would it be then?
84%. Oh, we don't know right now in class. We don't know anything other than the empirical rule. Chebyshev's rule was for all distributions. So for all distributions, between 1 standard deviation is 0% at minimum. Between 2 standard deviations is 75% minimum. Between 3 standard deviations is 89.9% minimum.
Why is 1 0?
Because the way the formula works, it's
Oh, okay.
one. Yeah, that's the only reason why. Chebyshev's rule is it's exactly like the empirical rule, but for any distribution that's non-normal.
So what is the first standard deviation for Chebyshев?
0% is guaranteed between 1 standard deviation.
The empirical is 68, 195, and 47.
Yeah.
From these three bells, which one is empirical rule?
The bell is automatically empirical rule.
Which one is Chebyshef?
Chebyshev is if it's not a bell.
Oh, I get it. The second division.
Okay? All right, so I think that takes care of all the free response questions. We're going to move on to multiple choice. Multiple choice. Question 1. The median grade is between which intervals? Okay, so for number 1, remember that we're looking for the 50th, or I'm sorry, the middle observation. Hi. Okay. Hey, the Dodgers are up 2-0. 6th inning. You need to be patient.
You like baseball? Did you hear that they're changing? They're trying to like change the rules a little bit so that the game goes by faster.
They always do that.
Okay, well, yeah, they should not have 9 innings. 18 innings, it takes 5 hours.
I like playing baseball, but I don't like watching it.
Okay. Let's do this. Hey, by the way, I'm not forcing you to be here, so if you really want to do something else, you really should just do it. Okay? I mean it. You don't have to be here, so if you really have something else you need to do, just go ahead and do it and save us all. Okay? Okay, moving on. We want to find the median of 100. So basically, the median of 100 means that if you put the numbers in order, okay, then the median would be the one that's exactly in the middle of the 100. So if you do your division correctly, that's going to be the 50th observation if we put them in order. Okay, so we don't actually have all the observations though. We only have this table of frequencies. We know that between 61 and 70, there are 16 different observations. We know that between 71 and 80, there are 42 different observations. We want to find, in order, the 50th from the bottom, because that would be the median. Okay? We don't know where what that number is exactly, but if you notice, you know that between 61 and 70, that's 16 of the observations. So that's not 50 of them yet, right? The 50th observation is not between the first 16 observations. Okay, the next one then, that's going to be the 17th observation to the, I don't know what 17 plus 42 is, 58?
Yeah, 58.
17 to the 58th observation.
Yes.
So the 50th observation from the bottom has to be somewhere in that between 71 and 80.
That's it?
Yeah. So observations 1 through 16 are between 61 and 70, right?
How is this multiple choice?
He takes it, multiple choice is and then multiple choice is type the question.
Observations 17 through 58 are between 71 and 80. Okay. Since we're looking for the median, we want to know where the 50th observation So the 50th observation is between 71 and 80. We don't have to know exactly what it is, we just need to know where it is. Questions on that? I hope that was easy. Praying. Number 2. The distribution of actual weights of an 8-ounce chocolate bar produced by a certain machine is normal with a mean of 8.1 and a standard deviation of 0.1. I'm going to write those down now because I know that they're going to be important. The mean is equal to 8.1. The standard deviation is equal to 0.1. Yeah?
Is the mean the 0 point?
Yes.
So not the
It's
median.
exactly the middle.
Okay, so it's
Remember that in a single peak symmetric distribution, the mean and the median are the same number.
Oh yeah, yeah. Okay, perfect. Thank you. That's important.
Yes, it is.
Right. So single peak symmetric is the same thing as saying normal.
No, not exactly.
But in this case,
So it's the 0 in the middle.
Normal means single peak symmetric, but single peak symmetric does not necessarily mean normal.
okay.
Okay?
Okay, yeah.
They're close to the same thing, but they're not exactly the same always. Okay, so the proportion of chocolate bars between 8.2 and 8.3. Okay? So let's figure this out. We're going to use the empirical rule. Where is 8.2? Actually, we should draw that bell curve. Let's draw a Darth Vader helmet. Darth Vader helmet looks like this.
8.1 would be in the middle.
It's between 2 and 3. Plus 2 and plus 3.
Right. 8.0, 8.1 would be in the middle. And that would have a z-score of 0. Okay. Standard deviation 0.1, so 8.1 minus 0.1 is 8 even. That carries a z-score of positive 1. 8.1 plus 0.1 is 8.2. That has a z-score of plus 1.
See you tomorrow.
See you tomorrow. Good luck. Next, we're going to have to take a look over here. That has a z-score of -2, and 8 minus 0.1 is 7.9. Here we have a z-score of +2. 8.2 plus 1 standard deviation is 8.2 plus 0.1, which is 8.3. So basically we want to find the area here. Okay? So let's remember, do you remember the area to the right of z-score of 1?
Yeah.
It is 6.16. We just did that, right? And then what is the area to the right of +2?
.025.
It's 0.025.
How do you find the area?
It's you have to memorize it.
Just memorize numbers, or is there a formula?
Yeah, it's the empirical rule.
It's large Q.
Okay, so we got that. If you want to know the proportion between here and here, was it relevant?
Yeah.
Yeah, go.
How come you're writing +1 but you're only adding 0.1? That's just empirical rule?
Because the standard deviation is 0.1.
Okay.
So here we're adding 1.
Yeah.
Here we add 0.1.
Okay.
Okay, so if I want to find the area of the yellow portion right here, okay, the proportion between 8.2 and 8.3, that's going to be the area to the outside here, 0.16, minus the area over here, which is 0.025, and that area is 0.135.
Yeah.
0.135. Yeah.
We could also just do it like the 95, which is +2 minus 2, minus 68, and then divide by 2, so you get the
You could do that too, yeah.
Is that a P?
That's a P, yes.
So,
Proportion or probability.
so 8.2 is greater than X is less than 8.3.
Yeah, you know what I should do? I'm sorry. Let me do this before you finish with that. Before you continue writing. This is 8.3, right?
Yeah.
So,
Wouldn't it be, wouldn't it,
hang on.
wouldn't it be 7.9?
Okay. So what we're really doing is we're actually normalizing. This is the same as a probability that a z-score is between 1
So this
and
is just
2.
getting the z-score.
Yeah. A good job here would always be to standardize.
Would this be the answer that you want to see something with probability?
If you were going to write it out, yeah, I would love to see it like this.
Okay, but if we're not writing it out, but this is going to be a multiple choice question. Okay, so, but is the answer going to be stated like probability? Is it going to be stated like are the answers going to have the P and then the probability?
No, if this question is just going to have numbers.
Okay, and so if their answer just has numbers, can you show me an example of like how it would look if it's just has numbers?
Yeah.
Would it just be asking for the area?
Yeah. Well, no. It would be asking for. It'd be the same question, but the answer choices would just be numbers.
So in this question, the answer would be 8.3.
0.135.
Which is the z-score?
Which no, that's the areas. I think that's our pizza.
Oh my god.
Should I look at it?
Yeah. Oh, let me give you a tip for them.
You should have ordered water. We got soda. I love it. I need water. I'm so thirsty.
Need help?
Okay, so we're gonna pause it here.